Okay. In the last video, what we did was we went over signaling and how signaling works within the application. I think next, an interesting thing to kind of cover would be this Theora texture object and Theora texture. Um, these are both utilized for the purpose of rendering video content to textures directly. So to give you an example of this, I'm going to go ahead and start the application and continue through it until it's actually running. Give it a second. Okay, continue all the way into the application. I'm just going to show you what an example looks like. Okay, the mission is starting. It's running all its torque script, whatnot. Let's continue. This is just some breakpoint action I have set here, so I could analyze name texture targets. Ignore this for now. Continue. Okay, here you go. You see that big black dome over there? It should be playing a texture. This texture is actually taken directly from an Aurora Borealis example I found on the internet. I'm not sure who the author was. I could probably find it if I'm looking. And if you are watching this author, whoever you are, sorry for not knowing your name. But he created a texture dome that is basically a giant three-dimensional texture, which is being painted to by that um, Theora texture object. It's being directly mapped. So if we actually go into torsion, we can see singleton Theora texture object. If you don't have torsion and you're doing development with torque, I highly recommend you change that and actually get torsion. If not, it'll take you significantly longer to understand this, the entire way that this application works. It's because you can set breakpoints, and just like how in the main application you can set breakpoints and follow through execution, well, here you can actually set breakpoints and follow through execution in TorqueScript, not in C or C++ or assembly, whatever you're looking at. Um, to use it, really easy. Create a Theora texture object. In this case, we're naming it Sky Video. Set the texture target name. This is a named texture target. Set your Theora file here, whatever you want to run. You can see this video abshq4.ogv is actually located in here. And then set a new material. Map the diffuse map, which is the basic first map, the bottom level map, I believe, to pound video. If you remember, we named it video. We'll map it to video. It doesn't have to be named video. You can name it whatever you want. We can name video, go, as long as we map the one on the bottom to that, then it'll work. In the game, if we actually look at the material for the dome, it's going to be this. So hold on, actually let's do that. Let me see if I can bring up the editor. Yeah, we brought up the editor. Okay, let's click on the dome. Let's view the material. Continue. If we look at the material over here, you can see video surface matte. If we look back in torsion, video surface matte. So, bam, bam. If we look in the application, we can see the dome here, and that's it. So again, play, go back in the map. It does take a second to load the video, and I think it's because this video is pretty large. It would be better if it was done with just like stream buffering. And I guess it's not even starting this time for whatever reason. I guess when you enter the editor, it stops it, and then there's just no resume. But yeah, that's the Theora texture object in use. So hold on, let's escape. I'll check how much video we got going so far. Okay, current file size is 125. Sorry, there's a limit on how big I can go. I just gotta be careful. Nope. Um, so what we're going to be wanting to do in order to make this happen is we're going to replicating uh, Theora texture and Theora texture object in their own objects and kind of using these almost as a template. Not a literal template, like we don't want to like abuse the privilege of having code available here, but we can create our own templates that basically create frames as we go along. My ideal is to create frames from window handles using the Paint Window API, and thereby, painting 3D windows in a sense. But if I can do that, it's kind of, sky's the limit from that point. But yeah, the way it works is frame read item exists. Let's go to definition as a thread work item. If you remember in the previous videos, that the thread read item is how work is actually dispatched to work items as they exist. So you can see how they're reading m frame stream, read frame. You can see how it's copying the data into the texture. You can see how the texture is actually being written. And then I think this is a notification on arrival. Go to definition. On arrival, buffered elements pushback. And yeah, that's it. So let's look at Theora texture object.cpp first. You can see class Theora texture object, public sim object. You can see odd add, odd remove, play, stop, pause. Let's look at the CPP. So console documentation, class constructor. So here you can see bind. Remember, well, if we were looking at the signals before, there were delegates. Um, Delegates were notification delegates. This looks like the bind looks like one of the invocations of notify. Hold on, is this a signal? Oh, it's just a fast delegate. Okay, so here you can see bind, which is going to bind the function. It's going to bind this to the texture, I guess, before it renders. Hold on, go to definition. Okay, here's where the texture is registered. Okay, here's where the console methods are added. These are actually accessible through script now. This is something we haven't covered before. You can see define console method, Theora texture object, play, name of the function. If we look in torsion, we can see up here this stop, this play, etc. This is where they're added. Stop and play and pause. That's where they come from. Mm. So mtheora texture is in the class. It's actually in the Theora texture object class. Um, and hold on, you can see get texture here. Mm, get texture returns current frame m texture. Okay, I'll go back. Find all references. Hold on 1 second. I think what this does is it just binds this routine here to the text target. I'm not sure exactly. I'm going to have to investigate a little bit more how things actually work, but it is important if you want to understand direct to texture rendering, if you want to be able to manipulate your application in that way through engine modification. It's important to understand what goes on in this Theora texture object and Theora texture. Like I said just a few seconds ago, I'm going to spend a little bit more time studying it, but for the sake of documentation, just covering the basics, I think this video suffices. The next video will be more in detail, and we'll actually use our own code. So yeah, in the next video, I'm going to duplicate all of the code from Theora texture object and Theora texture into my own module down here for the texture mapping, and I'm going to whatchamacallit, and I'm going to use my own naming conventions to see if I can get custom objects implemented into the rendering engine. Ideally, really, if I can get this black sphere to render a window, it'll be pretty awesome. And that's really what I'm going for here, is awesome. So I'm going to awesomely stop the video right now. That's it. Dope.